The following is the video solution from JSDT Solutions. Question 6, and just note that in question 6, 7, and 8, we need to give reasons for any statements made. Okay. Question 6 says, given triangle ABC with DE parallel to BC as shown in the figure below, we need to prove that AD over DB is equal to AE over EC. Okay, so we need to prove the proportionality theorem. Okay, so to prove the proportionality theorem, we first start off by drawing heights. Okay, so heights for these triangles. So we're looking at this triangle ADE, and we're going to draw a height for it because we need to include AD, right, and AE, of course. Now, one way that we can do that is to make AD a base of this triangle ADE. So in order to use that as a base, we also need a height. The height of this triangle, if this was the base, it will be drawn from the highest point of the triangle down to the base, and it will be perpendicular to that base. And we're going to go ahead and call that height H. And then to include AE, we're also going to use AE as if it's the base of this triangle. And if that was the base of the triangle, then the height of this triangle can be drawn from D all the way to AE, and it will also be perpendicular to AE. And we can go ahead and call that height K. And now, to use DB and EC so that they can also be included in this calculation, we're also going to use them independently as bases. Okay, so if this is the base of a triangle, you can see that we don't have a triangle here. So what we're going to do is form one. And we can form a triangle here using DB as the base, and we'll do that by joining E and B. So now we have this triangle BDE. And then we're going to do the same thing on this side to make EC a base. So we're going to look at EC as if it's a base, and we're going to form a triangle here joining D and C together. Okay, lastly, make sure to write down any constructions that you have made. Okay, there we go. And now to prove this theorem. So we're going to use these sides as the basis of their respective triangles. And in order to do that, let's go ahead and take a look at this triangle on top. But we're looking at this with this being the base of this triangle. So triangle ADE. Since we're using their bases, we're going to use the areas of these triangles, okay, in order to include these dimensions, these bases. So looking at this triangle with the base AD, we're saying that is triangle ADE, and we're going to find the area of triangle ADE. And this is equal to a half multiplied by our base multiplied by our height. But let's go ahead and see what the base is here. We already said the base is AD, and we can see that the perpendicular height that we have is H. So multiply by AD multiplied by this height of H. And now we're going to put this area of triangle ADE, we're going to put it over the area of triangle. Just note how this has been written. It has been written as AD over DB. So we're going to put it over the area of the triangle with DB as a base. So here is our triangle. You see that here's where we have DB as a base, and it is this triangle BDE. So we'll say over the area of triangle BDE, and this is equal to a half multiplied by its base, BD, multiplied by its height. Now, looking at this triangle, do you see that this is an obtuse triangle, okay, with this being an obtuse angle? So with this triangle, what exactly would its height be? Well, if you extended the base and you went all the way to this point, do you see how this, right, this height has been drawn from the highest point of the triangle E, which is also the highest point of this triangle BDE, and then down to an extension of the base, and it's perpendicular to that line. So it means that H is also the height of triangle BDE. Okay, so we can put that down. So when we say multiply by the height, we're also saying multiply by H. And there we go. So now when we simplify this, you see that a half and a half are exactly the same. They would simplify to 1. And then H and H also cancel. So this is simply equal to AD over BD. Okay, so we've got this side. Now let's take a look at this side. AE over EC. With AE over EC, if AE was the base of this triangle, we would say to find the area of this triangle, again, we're going to say area of triangle ADE, okay, but AE is the base of the triangle this time. So we're still saying area of triangle ADE over, and remember the whole point of doing that is to get to this point AE over EC. So we're taking AE as the base and then EC as the base of this other triangle that we have here. Okay, so let's just write down what that would be. This would be equal to a half multiplied by its base, which we can see is AE, multiplied by its height. And you can see that if this is the base of the triangle, then the height is from the highest point down and is perpendicular to the base. Okay, so that is K. So multiply by K. Now, the triangle that this goes over is the triangle with EC as a base. You can see that this is this triangle DEC. So DEC has this base EC, and what is its height? Well, that would also be measured from the highest point of this triangle DEC down to the extension of the base, and it's perpendicular to that. So you can see that that is also the height K. So they are sharing a height, just like these two triangles, the one with the base AD was sharing a height with this one. Okay, so to find that, we would say over, and we're just saying the area of triangle. So that is triangle DEC. So over the area of triangle DEC, which is also equal to, we'll say equal to a half multiplied by its base, which we could see was EC, and then multiply by its common height, which is also K. And then likewise, these also cancel. So a half and half cancel, K and K cancel, and we're left with AE over EC. Now, just because they simplify to AD over DB and AE over EC doesn't just automatically mean that they are equal. We would still need to find some logical reason for them being equal. So let's take a look at their areas. You see how in this triangle, we use the area of triangle ADE, and here the area of triangle ADE. So that means those are exactly the same because we're using the same triangle. Okay, we just looked at it differently, okay? Looked at the bases as if they were different bases. So we can say that the area of triangle ADE is equal to the area of triangle ADE. It's still exactly the same, okay? Same triangle. But now these two triangles on the bottom, BDE and DEC. Let's look at those triangles. With these two triangles, do you see how if you look at them as if DE is their base, then it means they have the exact same base. This triangle BDE and the triangle CED, they have the same base, okay, if we look at them like that. And how would we measure their height? Well, you would measure their height from the highest point of the triangle, B, okay, and this is also C, the highest point of that triangle, the blue triangle, and you would measure it from that highest point down, okay, and it will be perpendicular to the extension of the base. So if we extended that base, it would be perpendicular to that. Now, do you see how this is exactly the same? If you also have to measure from here to this base, okay, the extension of the base, do you see how these heights are exactly the same? And the reason they are the same is because they lie between parallel lines, okay? So their heights are exactly the same. And so that's what we can state here. So we can state that the area of triangle BDE and the area of triangle DEC are equal. So we'll tell them that the area of triangle BDE is equal to the area of triangle DEC. And they're equal because they have the same base and they're between parallel lines, so they have the same height. Okay, they have the same base DE and they lie between parallel lines, so their heights are also the same. And now because we were able to conclude that they were equal, we can therefore say that this means that the area of triangle ADE over the area of triangle BDE is equal to the area of triangle ADE over the area of triangle DEC. And so it means that whatever they simplify to would also be equal. So that is AD over BD, or I could really have just called that DB since that's how it was written. Okay, so that is AD over DB, and that is equal to AE over EC. and that is how we prove this theorem. And that is it for question 6.